Welcome back. In this video we're going to look at types and type conversion. So we've seen in previous videos that we have a range of types and they can be of different sizes. Okay, so you can have some big ones, you can have some little ones, etc. And basically it dictates how much memory they take up and also how we read that information. Now, what we want to have a look at is basically, to start off with, we're going to have a look at arithmetic operators and how they deal with types. So if we've got some arithmetic operator like plus, minus, times, and divide, we have two operands, okay, so that's what they work on. And what has to happen is when we evaluate this, what the computer does is it requires both operands to be the same type. So if I have a small type and a large type, what it will actually do is it will convert this such that this little type becomes a larger type to do the arithmetic operation. And then the result will be that larger type. So this works with all of our arithmetic operators, such that if we've got a little type and we add it with a larger type, then we get the little type converted up to a larger type. And then the result is that larger type. Now, the other conversion is when we use assignment. So remember, in C and most programming languages, this symbol here is assignment. It's not equals, it's not mathematics, okay? I like to use the word becomes, but assignment becomes something like that is fine. Don't use the word equals because that has a different meaning. So what happens here is that we've got to remember that on the left-hand side is where we want to store something, okay? And on the right-hand side will be some value, okay? It might be an expression, so 1 plus 1 gives 2, and then we go and store it. Now, we cannot, let's say I've got a really large type on this side, and I've got a little type on this side. I can't store all of this information into here. But if I have a really large type on the left-hand side, and I've got a small type on this side, yeah, that's going to fit. However, for both of these examples, the assignment requires that both types are the same, and we cannot change the left-hand side, okay? We can't change the storage, okay? So here, what's going to happen is this larger type is going to be converted down to a smaller type, and then we do the storage. Where in this example, the smaller type gets converted up to a larger type. I don't know why I drew that twice. Such that we can do the storage. Now, this here is perfectly safe. Okay? The reason for it being perfectly safe, if I've got a number like 64, that's definitely going to fit into the range of this larger type. Okay? Because we're only using this little amount of information. However, this can be dangerous, okay? So this one can be dangerous. So let's say the range of this little bit of information is only up to 100, and I try and store 1,000 in there, I'm going to corrupt my data, okay? However, if this larger type is only storing a very small number, so let's say it's storing 4, then this conversion will be fine, okay? So if if the information is in this region, so you can think of it as being a small number and it will fit into the smaller type, then this conversion will be fine. This is called converting down, and this is called converting up. Okay? So when we convert down, we may corrupt our data. Okay? And you need to be careful. Alright? This is all done automatically, so you won't see it happening, but you'll see your results come out badly if you haven't thought about this. And this comes about by thinking about your domain and how large the numbers are going to be. And thinking about how do I get the number such that it only exists within this range, even though I've got a larger type. So we'll continue by actually having a look at some code. Now, I mentioned earlier that the types have different sizes, so long has 4 bytes. Now, int can either be 2 or 4 bytes, and it depends on the actual computer system they're using. So C actually changes depending on the computer system. Here in this example, we're using 2-byte ints. Given 2-byte ints, it can only store this range of numbers, and long can store this range of numbers. So we have a look at this very first line here, and we've got int a becomes 5. So we're declaring a as an int, so a can only store numbers within this range. Okay, it cannot store numbers outside of that range, and if you try and put numbers larger, you will corrupt your data and you'll get results that you're not expecting. Now, this here we've talked about a little bit, and we know this is a literal. We know this is a decimal literal, but it also has a type. When we specify a literal like this, so we just write the number, it's an int. Okay? It's guaranteed to be an int. So this here can only be 2 bytes for our computer system. Now I'm going to use a slightly different notation here to represent this line of code. And I'm going to represent it in terms of its types. So we've got an int on the left-hand side, and we've got an int on the right-hand side. Now, as I said before, the assignment, both types have to be the same. They are the same, so we can store that directly into that, and that's perfectly fine. The next line here, we've got this 4 on the right-hand side. Once again, it's an int, okay? But on the left-hand side, we have a long. So if we have a look at this, this isn't going to work directly. Rather, this I needs to be converted up, okay, to the largest type here, which is the long, so that it can be stored inside the long. Okay? So we're converting up. Now I've got this little table here so you can see which types are the largest and which types are the smallest. Okay? So we're converting up here, so the 4 becomes a long, and then we can do the storage. Now because we're converting up, okay, so we're going from something small to something large, that's perfectly fine. Even if I had 32,000 here, 32,000 will still fit within this range. Okay, so this is perfectly safe to do. The next line is a little bit more interesting. So on the left-hand side, we have an int. And on the right-hand side, we have b, which is a long, plus 1l. So this is a little bit new and interesting. So this is a literal. It's a decimal literal, but its type is long. So if you want to specify a literal and its type, in terms of long, you can put L here. Okay? There are lots of different ways you can specify literals, and you can check them out on your reference sheet. So, we've got a long plus a long. Now, In terms of order of operations, the right-hand side needs to be completely evaluated before we do the assignment or storage. Okay, so this could be lots and lots and lots of maths. All of that has to be evaluated to one value before we can store it. Okay, we cannot store this whole block into here. We have to evaluate it to one value and then we can store it. And that's the reason that the right hand side needs to be evaluated completely before we store it into the left hand side. So here we just look at the right hand side to start with. Once that's all one value, then we can go and do some storage. Here we have a long and a long. Now, as we said, with arithmetic, they both need to be the same type. They are the same type, so we don't need to do any conversion here. And the result will be the same type if they're both the same, so we get a long. Okay? Now, we've fully evaluated this right-hand side, okay? But now we have to go and store this long into an int. Remembering that we're storing something big into something little, okay? So we actually have to convert down, all right? So converting down, we get an int becomes an int, and that storage is fine. However, because we're converting down, we have to be very careful. If our number is very large, let's say it was 2 million, it wouldn't be able to be stored into an int, and we would have corrupted our data at this point, and we would have garbage values coming out for our results. However, in this example, we've got 4 plus 1, so it's 5. 5 will definitely fit in both int and long. So the converting down is fine, okay? However, if we did 4 plus 2 million, then we would have just corrupted our data, okay? And instead of an int here, a long would have been suitable. All right, now we're gonna have a look at the next example we've got here. So here we've got C becomes C plus B times 2, okay? You'll notice that I'm saying becomes, it's not equals, okay? Get used to that. I know it's hard. All right, here we've got int becomes int plus b's a long times an int. Now, the first thing that's going to be evaluated is the right-hand side. Now here we've got multiple arithmetic operators, and with this we just follow the rules of BODMAS. There is a longer list for C because we've got a lot of symbols and a lot of operators, but for right now all we care about is arithmetic operators, and so because of that we can just think of BODMAS. So the first thing that needs to be done here is the multiplication. So we've got a long times an int. Now this int is too small to do this multiplication because we've got a long here. So this int needs to be converted up to a long so that they're both the same type. Okay, so they'll both be converted to the largest type. So the long times a long. And we're converting up. Okay, whenever we convert up, that's fine. We don't have to worry about it. The result will be the same type. So we get a long here. And then now that that's evaluated, we've got a int plus a long. The largest type here is a long. So the int needs to be converted up to a long. We have a long and a long, which gives a long. And that leaves us with I becomes, int becomes long, we need to store that long into an int. As we know, we can't do that. We need to convert this long down to an int. And this is converting down. So this is perfectly safe. This is perfectly safe. This might not be safe. Okay? It depends on how big that value is. Okay? If that value is very big, then that casting down may corrupt our data. Alright, so the same thing applies with floating point numbers. So here we've got float w becomes 1.0. Now this literal here is decimal, okay? But it's actually a double, okay? So when you write anything with a decimal point, it'll actually be a double. You can specify it as a float by putting the letter F at the end, but here we've got a double. So here we've got F and D for double, okay? And we can have a look at our list, and float is smaller than a double. So this double needs to be converted down to a float, and then we can do the storage. Remembering that because we're converting down, we may corrupt our data. Okay? So here you might want to put F here so that you ensure that you only store a float into here. And if we have a look at this last example here, we have a double becomes W, which is a float, plus B, which is a long. We have to do the right-hand side first. We've got a float and a long. The largest type here is a float, so this long needs to be converted up to a float. And then the result will be a float. Then this float needs to be converted up to a double so that we can store it into a double. And this is all perfectly fine. With that there, you cannot corrupt your data because you're converting up both times. Alright. So one thing that a lot of students do, especially early on, is they don't want to deal with this stuff, and so they'll just use double everywhere. This is not acceptable in this subject, nor practically. The reason for that is that you're being completely memory inefficient. You're just using the largest type everywhere. So now we'll go on to the next example. Alright, so in this example, we've got a common problem which is called integer division, and usually causes a lot of problems with people starting off in programming, and so we want to get it sorted very early on. So here we've got two ints, which is 4 and 2, stored in A and B respectively, and then we've got this division of these. So we're going to go 2 divided by 4. So if we have a look at this, this line here, we've got float becomes int divided by int. And if we want to have a look at it in terms of values, we've got 2 divided by 4. Now, as we know, with our arithmetic operators, we need to convert to the largest type to perform the operation, and the result is the largest type. If they're the same, then we just perform the operation and we get the result as that type. So the result here would be an int. Now if we go 2 divided by 4, most of you would be expecting 0.5, but that's not what you get. You get 0 because an integer is a whole number, and an int is a type of integer, and so we truncate the value and we lose that information. So 2 divided by 4 in integer division gives 0. Now, this is evaluated to this, okay? And now we've evaluated the right-hand side completely, so we need to do the storage. Now an int won't fit into a float because it's a smaller type, so we need to convert it up to a float, and then we can do the storage. So what happens here is the 0 becomes 0.0, and then we store it. So you can see how this can cause you a lot of problems if you're not careful. So we're going to have a look at two more examples here, and these are important, but we're not going to use them practically. We'll show you a better way of doing it. But the reason I want to show them is because in mathematics, the ordering isn't important here, but in code it actually is. So even though these look pretty much the same in mathematics, so you've got 1.0 times b over a, or b over a times 1.0, you'd get the same result. The f just specifies that I'm using a float here. So you'd expect the result to be the same in mathematics, but it's not in the code. So we'll have a look at that. So we'll have a look at this example first. So we've got a float becomes a float times a int divided by an int. So I'll put the values somewhere as well. So here we've got 1.0. I'm not going to put the f. I think it's clear. And we've got 2 divided by 4. Now we have to evaluate the right-hand side first, and our order of operations will be that we do the multiplication first. Now here we've got a float times an int. We need to convert to the largest type, so the int will be converted up to a float, and we get float times float, which will give us a float. So if you have a look at it in terms of values, we have 1.0, the 2 gets converted to a float, so we get 2.0, and then the result of this will be 2.0 divided by 4. We've got a float divided by an int, so the largest type here is a float, so this int needs to be converted up to a float, so we get a float and a float, and the result will be a float. So the 4 will get converted up to a float, so we get 4.0, 2.0 divided by 4.0 will give 0.5, and we've got a float on the left-hand side, so there's no need to convert anything else, and we correctly store 0.5 in here. Here we store 0.0, and we'll have a look at this last example, because this is where you can get into trouble. Now, this here isn't the solution to the problem. It's one solution, but it's a bad solution. We'll look at a better solution shortly. So here we've got float becomes int divided by int times float. Now, order of operations, we do the right-hand side first. And if we have a look at this in terms of values, we've got 2 divided by 4 times 1.0. Int divided by int, we don't need to do any conversion. We get an int result. So we get 0 here. We've got an int times a float, so the int needs to be converted up to a float, and then the result will be a float. So this 0 will be converted to 0.0, we times that by 1.0, and we get 0. The result is a float, the type we're storing it into is a float, so that's perfectly fine, and we get 0.0 here. So the only one that worked how we wanted it to was this one here, D. Okay, so we have to be careful with our integer division, and we'll show you a way of doing this properly so that you get it right all the time. And that's the next example. Alright, so this example looks fairly similar, but we've got this thing in brackets. And it's a type inside of the brackets. And this is called a typecast or explicit typecast. So basically what this does, it will convert the value next to it into that type. Now, it has, in terms of precedence, it's just below brackets. Okay, so brackets will come first, then your typecasts, then your arithmetic operators. There are other operators, but for now, that's all we need to know. So here we have float, typecast float, int divided by int. Now, as I said, the float has higher precedence than our division. Okay, so it has higher precedence than our arithmetic operators. So the first thing that will happen is this int will be converted to a float. Okay, and if we have a look at this in terms of values, we've got float 2 divided by 4. So what will happen here is the 2 will be converted to 2.0. Then the division, there's a float and an int, so the int needs to be converted up, so we've got the largest type, and then we've got a float divided by a float, and we get a float. So this 4 needs to be converted to 4.0, and the result is 0.5. So this works, and this is the correct way of doing it. Now, if we have a look at this second example, what we've done instead is we've converted the a to a float rather than the b to a float at the start. So we've got f is I divided by typecast int. Now, order of operations, it's going to convert this int to a float first. Okay, it has higher precedence than the division. We've got an int and a float, so we get a float divided by a float, and the result will be a float. So this one works as well. This last one is where most students make the mistake, and you need to be really careful. This last one, we've got a float becomes typecast float brackets int divided by int. Now, the typecast has higher precedence than the division, but it doesn't have higher precedence than the brackets. Brackets have a higher precedence. So with this, we actually do the division first. And if we divide these, we get an int, and then we convert that result to a float based on the cast. So with this, we have 2 divided by 4, that will become 0, and then it will become 0.0. So this one gives us 0.0. So you need to be careful with your brackets. Basically, your brackets say we want to do that thing first. Okay? So you can put the typecast at the bottom or the top of your division, but you can't put the whole thing in brackets and then the typecast in front, because that won't work. Alright, hopefully that all made sense. It is a lot to take in, but you'll get some practice in the lab with it. Thank you.